Hi, this presentation is going to show an example of how to take a slice and move it through a domain. This is an example of a slice moving through a domain. And what we're going to see here is we have the vectors shown on the slice. These vectors are only in the plane of that slice. And the slice is actually set up to move downstream and around a bend. So I'm going to show a more simplified version of how to take a slice, move it downstream, and also have the camera follow the slice at the same time. So let's go ahead and get into that. So first we're going to open our foam.foam file or our .foam file, and we're going to hit apply. And this is a very small file, but it showed up pretty quickly here. This does have a time step that's converged for the solution here. So we're going to do an ISO volume with the filter and isolate the alpha dot water that's between 0.5 and 1.1 in case there's some alpha dot waters that are a little higher than 1, which in some cases it is. And so here we have our isolated water surface, or our water volume in the flow domain. And now we're going to have a slice in this domain, and the intent is to try and get this slice to move downstream, and we can look at the surface vectors on that slice, but have it also animated. So this is a convenient thing to do if you only have one time step and you want to look at some of the dynamics of the flow, but you also want to create an animation. So the first thing we're going to do here is on this ISO volume is apply a filter to it and put a slice through it. And I want the slice to go in the Y normal direction. And I'm going to drag the slice upstream a little bit, like this. And that's where I want my slice to start. And then we can go ahead and go to the view and turn on the animation view. We'll see this come up here. Now, what this is showing us is that we're looking at a sequence right now that's snapped to the time steps. We do want a sequence. We're going to just arbitrarily pick between 0 and 100 for the start and end times, and this just helps us in the simulation figure out where we want things to change and happen. And then let's go ahead and give ourselves about 1,000 frames, and this just helps set up the animation to run smoothly later on. So I haven't yet clicked apply on my slice, but I'm going to go ahead and do that. Okay, so now we see the slice there. I'm going to turn my ISO volume back on actually, and I'm going to make it a little bit more opaque. So now we can see where that slice resides. Now what I'm going to do is turn on a filter on the slice called Surface Vectors. Apply the glyph filter. I don't want to scale it, so down here where it says orientation with velocity, yes, I want the velocity. Scale, no, I'm not going to scale it for now. I'm going to make it a solid color, and my preference is a black vector there. So now we have the surface vectors, which I can make velocity, and the glyph, which is showing us the orientation of the velocities in that plane, just the vectors in that plane. And now we're actually going to animate. And what we want to do is go down to our animation view and choose the slice. That's what we want to change here. And what we're going to change on that slice, if we go to the slice, is we want to change how the slice is moving. We can see in the Y direction. And the Y direction is captured here in these origin coordinates here. So we're going to actually add the second origin coordinate as something that we want to change. It ends up being called origin 1 because there's an origin 0, 1, and a 2. The origin 1 is the Y direction for our simulation. I'm going to go ahead and add that for our slice. Now in this white space right here, we can double click on that. So from the arbitrary time of 0 to 100 that we've set up in our slice, that we've set up in our animation view, the slice is going to move from value 5 to 10. Let's just change that here from 1800 to 2200. And we're going to click OK. We're going to zoom out slightly by clicking on the ISO volume and snapping to that. And we're going to play this and just see how it functions right away. In bigger cases, this will take a long time to animate and run through, but for a smaller case here, we might actually be able to see how well the slice moves. In this animation control up here, we can hit the play button, and we can see that slice is starting to move downstream. So that looks like it's going to actually work out pretty well. I'm going to go ahead and say go all the way to the end here, and we'll see where the slice ends up. So I paused it and moved the slice all the way to the end. It looks like the slice went off the screen there. So let me see how far our Y direction goes. So our Y direction, you can see here from this coordinates, goes as far as 2160. So I sent the slice off the screen there, or off the domain. So I'm going to fix that here and just change this to 2100. And now the slice ends right here. That's where the slice will stop and the animation will stop. So this is great, but what if we actually wanted to follow the slice and watch what it was doing as it was moving through the domain? We can also add in here a camera. And in this drop down here, what do we want the camera to do? We want it to follow data. And we're going to go ahead and click plus to add it to our animation view. If I double click on camera now, what do I want it to follow? I want it to follow slice 1, and I'll click OK. I'll move the slice back to the beginning of the animation, and we actually follow the slice. The view changed based on me moving the animation back to the beginning. Now if we play the animation, we should follow the slice. And yes, we are following the slice now. I don't like how the vectors are turning on and off here, based on a setting I have for the vectors, so I'm going to pause this. So I need to go to the glyph setting here. And instead of a uniform spatial distribution, I'm just going to animate, or glyph rather, all points. Now I'm going to play the animation. And now we don't get those glyphs blinking so much. They're every single cell center, or cell face rather, it appears is now has a glyph. So we're following that slice downstream. Nothing really is happening because all the flow vectors are pointing down. There is a baffle block further downstream, though, that eventually we should get to. And as we approach that baffle block, we'll see the vectors will change to move left and right. And here we go as we approach that here. So the slice is going up, extending into this flow now. So I may scroll out a little bit. So 1,000 slices might be too much here. We can see the baffle block showing up now, and the vectors sort of push around it a little bit, and we get a little bit of a swirl there. So that's sort of giving us an indication of how this animation might work with other domains or with other flow situations there. This is a very thin simulation and just an example of what the moving slice can do. The other thing we can see here is we're not getting a very good representation of the velocity. Rescale to the data range for the velocity. And this might look a little bit more interesting. Because we're looking at the vectors in the left and right, the velocities are going to be a fraction of what we're having coming downstream. So now we can go ahead and try to save an animation. And I'm just going to call this test 1. But then I'm also going to change it to an AVI file. In the Save Animations options, we have 1,000 frames, and our frame rate, this is going to be sort of like what our eye detects for the moving frames. If we want about 30 to 60 frames per second, that's going to be a very smooth animation. But I'm going to go ahead and do 100 because I saw that the slice was moving pretty slowly. So this will end up being a 10-second animation, 100 frames per second. And I'll click OK. It did give an error, but that's just because the resolution was changed slightly. So this will change the animation from the view it looks like right here, but it will look pretty similar to what we want here. So I'll let that cook and then I'll be back in a second. And here we have the 10-second animation of the slice moving downstream. Now it does look a little bit like it's moving up and down and a little bit finicky at the bottom there, but that's because what we're following here is the slice, regardless of how big it gets. If we want a smoother animation, you could have something maybe more consistently a certain size, like a block mesh or something that acts as a rail that the slice is following or slicing through and moving downstream and stays the same size. So that's how you move a slice, and thanks for watching. And if you have any questions, go ahead and feel free to put those in the comments below and I can try to get to them. Thank you.